In 7e, we're going to use our force equation. K, the elastic constant, times L minus L0, and just remember that the L0 is the original length. So we have an original length or a natural length here of 5, and we're given the K is 10. So we're going to have 10 times 6 minus 5 for the first one, 10 times 10 minus 5 for the second one, and 10 times 5.2 minus 5 for the last one. In newtons, we're going to get 10 newtons, 50 newtons, and 0.2 by 10, 2 newtons. 2 newtons. Question 2, I have a natural length of 2, and I have K is 9. So we're going to have 9 times 3 minus 2, 9 times 5 minus 2, and 9 times 3 and a third minus 2 for my forces here. We're going to get 9 newtons, 9 threes are 27, and 9 by 1 and a third, 9 by 4 over 3, 9 by 4, 36 over 3 will be 12 newtons for part 3. And what is the length if we're given the force? So the force is 54. What do we not have? We don't have this length in here. So 9 times x minus 2 is equal to 54. Dividing by 9, we get x minus 2 is 6. So x is equal to 8, and we're dealing in meters, 8 meters. Number 3, we have a particle on a smooth table attached to 2 strings and 2 vertical walls. So I have vertical walls and I have a particle attached to these strings in the middle, or it doesn't have to be in the middle, but for diagram purposes, let's just put it here. And the left hand wall, we have natural, with the left hand string, natural length 1, so we have an L0 of 1. We have a constant, elastic constant of 2. The string on the right, we have again L0 is 1 here, and K is 4. And the walls are 20 meters apart, so we don't know how far this one is, but whatever it is, it's going to be on the other side 20. Take away that value, 20 minus x for the next few questions. So these are our distances. So let's have a look at filling this information into our formulas. We want the resultant force on the particle. So if we look at, I'll do this one first, and we'll call this the left hand one. So 2 by, we don't know x, well, we're calling it x minus the natural length, which is 1. So 2 times x minus 1, if they're in equilibrium, will have to be equal to the force of the second one. K is 4. We have 20 minus x as the distance, and we would have to take away 1 as well actually here. So 2x minus 2 is equal to 80 minus 4x minus 4. So bringing 4x to the left, we're going to get 6x is equal to 76 plus 2, 78. So x in this case is 13 centimeters, or meters. What are we dealing with? Meters, 13 meters. And that will be from the left hand side. And then have we another part here? We do. The position when they're in equilibrium, the forces will have to be, actually that's the position 2, that's the equilibrium, 13 meters. So actually I've done that bit first. The resultant force when it's midway, I need to read these questions correctly. So midway will be 10. So 2 times 10 minus 1 will be the force on the left hand side, which will be 20 minus 2. 18 newtons is the force on the left. The force on the right, K is 4, it's midway, and 1 is L0, so we're going to get 4 nines, 36 newtons. So the resultant force is 36 minus 18, which is 18 newtons for my resultant force. Here we have a similar question. The walls are 19 apart this time, so just a quick diagram. And we have natural length 1, K5, natural length 2, K3. So equilibrium, we're going to have, we're looking for the distance, so let's just call it again, we'll say x and 19 minus x. So k in the first one is 5 times x minus the natural length, which is 1. If it's an equilibrium, we'll have to be equal to 3 times 19 minus x minus the natural length of 2. 5x minus 5 is equal to 57 minus 3x minus 6. So bringing 3x to the left, we're going to have 8x. 57 minus 6, 51, and plus 5 is 56. So x will be equal to 7 meters from the left hand side again. And the resultant force has to be 16. We're going to have one force minus the other. So let's look at the force. Let's look at the individual forces first. And let them equal 16. It's probably the best thing to do. So let's say this is force 2 and force 1. Force 2 minus force 1 is equal to 16. Or you can call them force left and force right. So 3 times, this is 17 minus x. Minus the other force, which is 5 times x minus 1, has a resultant force of 16. 51 minus 3x minus 5x plus 5 equals 16. So we are going to get, what are we going to get? We're going to bring 8x to the right. We have 56 here and we're taking away 16. So that will be 8x is equal to 40. So x will be equal to 5 for the resultant force to have a magnitude of 16 newtons acting on the particle to the right. So we are correct in force 2 minus force 1. We'll have 16 newtons acting to the right if it's 5 meters away from the wall. Similar type of question, and we have the walls 35 apart. We have natural length of 2 and k7, and then we have natural length 3, k3. So equilibrium. Let's have a look at just the diagram. 2 walls. Where will it be in equilibrium? They're 35 apart, so we have x and 35 minus x. So k7 by x minus the natural length of 2 will be equal to k, which is 3, times 35 minus x is the position, minus the natural length of 3. So 7x minus 14 is equal to 105 minus 3x minus 9. So 3x to the left gives me 10x equals 105 plus 14 minus 9 will be 110. So x will be 11 meters from the left hand wall that we're dealing with here. 2 positions where the force will be 40. So we have F left minus F right, or F1 minus F2. Go left for L and right for R if you want. So we're going to have 7x minus 14. That's this force. If I take away the other one, we're going to have minus 3x, which is plus 3x. And I'll combine 105, that's 10, that's not plus 96, so it's going to be minus 96 will be equal to 40. So 10x is equal to 150, is it 150, 110, or 40, 150? So x will be 15 going in that direction. And then we reverse it around and we have 105 minus 3x minus 9 minus the other force, which will be minus 7x plus 14 equals 40. With 10x going to the right, it's going to be positive, equals on the left we have 105 plus 14 is 119, 110 minus 40 will be 70. So x will be 7 meters from the right. This is the left hand side and this is from the right hand side to give us a magnitude of 40. Question 6 has a mass involved here, so they're changing a little bit. We have a natural length of 1 and k of 50. And we have a horizontal table and a radius, so we're looking at the force towards the center here. So let's have a look here at my non-straight line. This is 2 meters, this is my radius. I'll have my force down this way, so I have mg. And I have my mass of 1, I have my k is 50, so what have I got? 50 times natural length of 1, and the radius is 2, so it's stretched out, 2 minus 1. That's the force towards the center. Or sorry, that's the force towards the center. It's going to be 50. Just 2 minus 1 is 1, yeah, 50. And then we're either dealing with mv squared r or mw squared r. So in this case, we're looking for angular speed, w. So this mw squared r is equal to 50. The mass is 1. The radius is 2. W squared. So w squared looks like it's 25. So the angular speed here will be 5 radians every second.